Let's create a JPA application using Spring Boot 3. We'll generate the project using Spring Initializer. Let's make it a Maven project, and we'll change the group to com.beginSecure and the artifact to JPA access. Next, let's add some dependencies. We'll need JPA. JPA, or Java Persistence API, is a specification for accessing persistence and managing data between Java and relational databases. It will remove the need for writing a lot of boilerplate code that we had to do in the past. We'll also need the H2 dependency. H2 is an in-memory database we can use to develop our proof of concept. It's nothing you'd want to use in production. You'd want to swap this out for Postgres, MySQL, Oracle, or something similar. Everything looks good, so let's click Generate. And a zip file called jpaaccess.zip is downloaded to our computer. Let's go to the Downloads directory and extract that. We have a new folder in our Downloads directory called JPA Access. If we plan on saving this project, we should move it to a different location. But for the purposes of this demo, I'll just leave it where it is. Now let's open up IntelliJ IDEA so we can continue to work on our application. From the IntelliJ welcome page, let's click Open. And then let's go find our application code wherever it happens to be. On my machine, it's in the Downloads directory. And let's select the folder where our source code is located and click OK. Because we downloaded this project from the internet, IntelliJ is asking us if we want to trust this project. I have a whole video on this topic linked here. Since we just generated this code and know where it came from, let's click Trust Project. Please consider clicking the subscribe and like button to help the channel grow. Thank you. I'll speed up the video while the project is loading. Let's take a quick look at the pom.xml file so we can see the dependencies that were added to our project. Now let's open up source main Java, and let's add a new package. We'll call it model. And in that package, we'll add a new Java class called employee. We'll use the employee class to manage the storage and access to our database table. Before we do anything, let's annotate the class with @entity. This annotation is used to indicate that an instance of this class will be used to persist data to our database. It's part of the JPA specification. Let's fix our import statement by pressing Alt-Enter. And now let's add the data fields to our class. First is private long ID. This will be the primary key for our class. Next is first name, which is the first name of our employee. Then, of course, last name. And finally, salary, which is of type BigDecimal. And again, we'll fix the import statement, this time for BigDecimal. Because ID is our primary key, we need to add some annotations so JPA will supply a value for the field each time we add a new row. @ID specifies the field as a primary key to JPA. And the @generated value with the strategy of auto means JPA will automatically assign the value to our primary key. We'll generate the rest of the code for this class. We'll create a constructor that will take all the fields except ID, since that's provided to us. And let's create a no argument constructor just in case we need it. And let's create getters and setters for all the fields. And finally, let's create a toString method so we can print out our results later in the lesson. And that's it. Let's scroll through the code so you can see what was generated for us by IntelliJ. Now let's add a new package called repository. And in that package, let's create a new class called employee repository. But instead of making it a class, let's select interface instead. And let's have it extend JPA repository. By extending JPA repository, our class inherits methods to perform common CRUD operations to create, read, update, and delete employee data, and will write almost no code. Now let's add the generic parameters employee and long. This tells JPA that the repository will manage instances of employee entities, and they have a primary key of type long. Let's fix our import. At this point, we're done with the database code, and we have complete CRUD access, which is pretty amazing. Let's say we want to add some custom finders. We can add them here, inside the braces. Let's add two methods. They will both return a single employee instance. The first is called find by first name. It takes a string, which is the name to be used in the search. The second method is called find by last name. The prefix findBy is the standard prefix used by JPA. Using the first name and last name values tells JPA to use the fields with the same name to generate a query for us. We don't have to write or manage the query. It's done all for us. Pretty cool. Okay, almost done. Let's go back to the main application and load some data, and then search for it. Let's add a method called loadData. It returns a command line runner and takes the employee repository as a parameter. The command line render interface is a functional interface in Spring Boot, and it's designed to execute code when the application starts up. We'll annotate it with @bean, so it's registered as a bean in the Spring application context and will be injected at runtime. The command line runner interface has a single run method which accepts an array of string arguments, so we could pass command line data to the method. However, we won't do that in this case. And the method returns a lambda expression which contains the code to be executed at startup. Inside the lambda block, let's create an employee entity and save it to the database using the save method of the employee repository. We'll invoke the 3-argument constructor we generated just a moment ago. Our first employee will be Bill Gates, and we'll add his salary as a new BigDecimal item. Let's fix the imports again, and to save time, we'll copy the row 2 times. Our next employee is Elon Musk. His salary is going to be double what Bill's is. And our third employee will be Jeff Bezos. He's just a little behind Elon on his salary. When our code runs, at this point, we'll have already persisted the data to the database. So now let's go ahead and read that data back out. Let's create a for each loop, and we use the findAll method that's provided to us by the employee repository. And for each employee, we'll simply print out their information. We can use the live template SOUT to generate the systemoutPrintLine method, and then we can print employee. The toString method we generated will be invoked implicitly. And now let's print out the salary of 2 of our employees. First, we'll simply write println, and we'll use the custom finder we created, findByLastName, and pass in the last name of Musk, and print out his salary. Now let's do the same thing, but this time we'll use the findByFirstName method. We'll ask for Bill Gates' salary and print it out. Let's format the value, however. There's a format method in the string class that will help us out. For the format string, let's enter %, .2, and then F. This will format the salary in the American style with commas and periods. I'm sure there's an international way to do this. Let me know in the comments what you find. All right, we're all done coding. Now let's run the code. And when we do, mixed in with our log messages, we see the output first from our for loop. Our toString method was invoked. Down below is the salary for Elon and Bill. Only Bill's is formatted though. Currently it's $1 million. That must be his salary per second. Okay, that's all for this time. Please share this video with others. Thanks for watching, and remember to always begin secure.